Welcome everyone to our chemistry remote learning class. Today is our first screencasted lesson, which is going to feature me speaking over the slides and delivering instruction. We're going to start today like we do every class with our mindful minute. So you guys know what to do. When you start these lessons, you should also be sitting at a table or a desk and ready with pen and paper. So we can sit with a mindful body where we are. If you need to pause and get settled, you can do that. And we will take deep breaths in and out through our nose together for 1 minute. So look for that sense of stability in your body. Look for the sense of stillness. And inhale through your nose, nice deep breath. Exhale, pushing the air out. Inhale, nice deep breath in. Fill your lungs. And exhale, push the air out. Again, inhale, nice deep breath. And exhale, pushing the air out. Inhale deeply. And exhale fully. Inhale that fresh, energizing oxygen. And exhale that stale carbon dioxide and any tension or stress. Inhale, energizing oxygen. And exhale carbon dioxide and any stress or tension. And allow your breathing to return to normal. Check in with how you feel. If any new sensations or thoughts have come up, just notice them and just be aware. Mindfulness is simply being aware in the present moment without judgment. And when you're ready, you can slowly blink open your eyes. And let's get started. So, lesson 2 for remote learning week 1 is titled Oxidation and Reduction Half Reactions. So, we are still in unit 4. We just had a review on ionic bonding, covalent bonding, elements, compounds, and mixtures. And if you recall, in ionic and covalent bonding, what did those two have in common? Ionic and covalent bonding both involved electrons. And as we continue in Unit 4, oxidation and reduction also includes electrons. So electrons are super important when elements are bonding together and chemical reactions are happening. Today's learning target. If you see this little icon in the top corner, this means you are going to write this down. We're not going to do a whole ton of notes, but you definitely want to have your learning target, which is I can write redox half reactions. Pause the video now so that you can write it down. And today's agenda is oxidation and reduction, also called redox, and then half reactions. We're going to have do now still with our lesson, and on your paper you can write out your do now and do this along with the video. So which of the following are ions? If you chose the following, you were correct. Cu2 plus, Ag2 plus, Al3 plus, and also SO2 2 minus. Now, one of these looks different from the other ones, and that's this guy down here. So this is actually called a polyatomic ion. Polyatomic, that word, means poly means many, atomic referring to atoms. So many atoms, an ion made of many atoms. This can be found on table E in your reference table. Polyatomic ions get their own special name, so that's why they're in this table. So if you ever see a question about polyatomic ions, table E is where you're going to want to look. All right, so what does a redox reaction look like? We're going to watch this experiment, and as we watch, I want you guys to notice what happens in the beginning, what happens in the end, and why might that be happening. So that is a little Christmas tree made of copper, same thing that a penny is made out of. Silver nitrate is the solution that's being poured into the beaker. There's our equation. And let's see what happens over time. And we'll pause here. So what did you notice was in the beginning? What did it look like at the end? And why might that have happened? Pause the video now and just think to yourself, why might that have happened? All right, so redox reactions can be seen in many places. When plants photosynthesize, they take light and they make glucose and oxygen. That is a redox reaction. When we consume, as consumers, the producers, we consume plants and use the glucose for energy in cellular respiration. That's a redox reaction happening. And one that you guys are super familiar with, ever present in our daily lives, our phones and our digital devices. The batteries inside of these devices are run by redox reactions. So you can actually thank chemistry for your phone and all the stuff that you do on your phone, and also life, because without cellular respiration, we would not survive. So we're going to watch this super thorough video about oxidation and reduction. One thing to point out, this icon in the top right corner is the Google Form icon. Notice it matches this. This means that when there is a video, when this icon is here, there are check for understanding questions that go with what's on the slide. So the questions in this form will go with this video. I strongly suggest watching this whole lesson through and then answering your Google Form questions at the end, because that way it's like you're quizzing yourself and you're actually using what you learned and assessing if you understand it.
This video is an introduction to oxidation reduction reactions. We often abbreviate oxidation and reduction, so we just call these redox reactions for short. So, what is an oxidation reduction or redox reaction? Here's a quick definition. In oxidation reduction reactions, electrons move between atoms. Check out this diagram here. We got atom A and atom B, and there's an electron moving out of atom A into atom B. So this is definitely an oxidation reduction reaction because there's an electron moving between the atoms. Now, we can describe the movement of this electron using the words oxidation and reduction. So let's learn specifically what both of these mean. Reduction is a gain of electrons. I know this seems kind of confusing because usually when you have a reduction of something, you have less of it. We'll talk later about why a gain of electrons is called a reduction. But anyway, reduction, gain of electrons, and then oxidation, which is a loss of electrons. So we got reduction and oxidation. What's happening to atoms A and B over here? Well, atom A is giving up one of its electrons. It's losing an electron. So at atom A, oxidation is taking place. Atom B is receiving an electron. It's gaining an electron. So at atom B, reduction is taking place. Now, we can modify these words slightly to come up with terms we use to describe what's happening to the atoms. Atom A is undergoing oxidation, so we can say that atom A is being oxidized. Atom B is undergoing reduction, so we can say that atom B is being reduced. So we got oxidation, oxidized, reduction, reduced. The big picture here is that reduction is a gain of electrons and oxidation is a loss. So I don't know about you, but when I was first learning this stuff, I found it so confusing. Why should a reduction be a gain of electrons? Usually when you're reducing something, you're getting less of it. So here's one thing that might be helpful to think about. That's that electrons have negative charge. So as you add electrons to something, its charge goes down. The more electrons you add, the lower the charge. So as you add electrons, as electrons are gained, the charge reduces. So that might be helpful to keep in mind to have this make a little bit more sense. Still, these things can be really confusing to remember. So here are a couple really great mnemonics. First is the term oil rig. This is the name of one of those big structures you use to drill for oil. OIL stands for oxidation is loss, and RIG stands for reduction is gains. This is a really good mnemonic. Here's another one you might like if you like animals. Leo the lion says grr. All right? LEO stands for loss of electrons is oxidation, and grr stands for gain of electrons is reduction. So learn one or both of these. They'll be a great way that you can always remember what reduction is and what oxidation is. Okay, oxidation and reduction happen in all sorts of chemical reactions. They're like the super important thing that makes those reactions happen, that makes them go. So to learn more about this stuff, we're going to have to look at an example of a chemical reaction where oxidation and reduction are taking place. Here's a chemical reaction that we're going to be talking about. Sodium and chlorine coming together to make sodium chloride, table salt. Now, sodium chloride is an ionic compound, which means that it's made of ions. Specifically, the sodium 1 plus and the chloride 1 minus ions. These two ions stick together because they have opposite charges, and opposite charges attract. Now, Na and Cl, they didn't always have charges though. Over here, before they combined, they have no charge. They are two electrically neutral atoms. So in order to come together and make sodium chloride, these two atoms have to end up getting charges and then they stick together. So let's talk about how this happens, how they end up getting charges. So we start out with Na and Cl here as electrically neutral atoms with no charge, and they're on their own, they're separate. The next thing that happens is sodium gives one of its electrons to chlorine. So this is where the charges come in. Sodium loses one of its electrons, so it becomes Na plus 1. And chlorine gains an electron, so it becomes Cl minus 1. Now we have two ions with opposite charges. What do oppositely charged things do? They stick together. So these two ions come together and they stick, making sodium chloride. Okay, so this is the process where we start from electrically neutral atoms. We have an electron transfer, we get ions that then stick together. So here's the equation that I showed you earlier that describes this process. There are a couple things that I could add to this, though, to make stuff a little clearer. Check out these numbers that I've written in here in the red. These are called oxidation numbers, and they give me a sense of what's happening with the electrons and with the charges. So above Na and Cl, I've written zeros. That indicates that these two atoms start out being electrically neutral. They have no charge. That's what the zero means. Then on this side of the equation, once the sodium and chloride have taken on charges, I put those charges above each element, plus 1 for the sodium and minus 1 for the chloride. These oxidation numbers help us keep track of how charges change during a reaction. Most importantly for this reaction, they remind us that sodium and chlorine start out neutral and only end up getting a charge later after this electron transfer takes place. So, that is oxidation numbers, and we'll talk more about those in coming lessons. So, obviously, this is an oxidation reduction reaction because there is a transfer of an electron between these two atoms. I now want to describe what's happening to sodium and chlorine using these terms reduction and oxidation. So, just to refresh your memory, reduction here is a gain of electrons, and oxidation is a loss of electrons. So, for sodium, what's happening? Is it being reduced or is it being oxidized? Well, sodium is giving up one of its electrons, it's losing an electron, so it's being oxidized. Here's a diagram of sodium giving up that electron. Now, chlorine, on the other hand, is receiving an electron. It's gaining an electron, so chlorine is being reduced. So there's oxidation and reduction going on here. We can sort of show this oxidation and reduction with this picture that I drew, or we can describe it in words. The next thing that I want to do is I want to show you how we can write chemical equations that show oxidation and reduction. So let's start out here with chlorine. I want to write a chemical equation that shows the reduction of chlorine. So I'm going to start out with Cl here. This is neutral chlorine. It doesn't have any charge. It's this thing here. And then it receives an electron. So to write an equation for that, I'm going to write plus E minus. E minus is a symbol we use for electrons. So Cl, neutral chlorine, plus 1 electron gives me this guy right here, Cl1 minus. So this is the equation for the reduction of chlorine, for chlorine gaining this electron here. Okay, now for sodium things are a little bit trickier for the oxidation. Let me show you why. So what I really want to write is Na minus 1 electron gives Na1 plus. But unfortunately, I can't write this because in chemical equations, we can't use minus signs. We can only use plus signs. So I can't write the oxidation like this. Instead, I'm going to write it like this. I'm going to start out with Na here, and then I'm going to put my arrow. So Na turns into Na1 plus 1 electron. Writing the electron on this side of the equation indicates that it's being spit out, that Na is losing it. It's no longer part of the atom. So to write reduction, we put the electron on this side of the equation because it's coming together with the atom. To write oxidation, we put the electron on this side of the equation because it's getting spit out. So these are the reactions for oxidation and reduction of sodium and chloride. Now I want to talk a little bit more about these two reactions and how we can combine them to make a larger, bigger picture equation. Here's our big picture reaction for sodium and chlorine coming together to make sodium chloride. Now, this reaction here really has two processes going on within it. One of these processes is the oxidation of sodium. It starts out at 0, loses an electron, and becomes sodium 1 plus. And here is the equation for just the oxidation. The other process that's going on in this reaction here is the reduction of chlorine. Chlorine starts neutral at 0, it gains an electron, and it ends up as Cl1 minus. And here is the equation for the reduction of chlorine. Now, these two equations down here are called half reactions. They show either oxidation or reduction, and they're called half reactions because they each kind of tell half the story. You put them together, and you get the big picture reaction that shows both oxidation and reduction. So for every oxidation reduction reaction like this one, you can write two half reactions, one for the oxidation that takes place and one for the reduction that takes place. Now, it's super important to keep in mind that oxidation and reduction always have to happen together. They always have to happen at the same time. Because if one atom is gaining an electron, that electron had to come from somewhere. So another atom had to give up that electron. You can see that right here. The electron here that chlorine is gaining is the same electron that sodium was releasing. So oxidation and reduction always have to happen at the same time. They always have to happen in parallel. You can't have reduction without oxidation. You can't have oxidation without reduction. So that's an introduction to oxidation reduction or redox reactions. We learned that reduction.
All right, we're going to stop there. And remember to go to your Google form and answer the check for understanding questions that go with this video. Now, a mnemonic that he mentioned in the video is oil rig. This one is, I think, the easiest to remember out of all of them. Oxidation is losing electrons and reduction is gaining. So when we're working through some of these problems, you want to think oil rig and what that stands for. So we're going to take notes, just 2 slides. We see our note-taking signal up here. The definition of oxidation is when an atom loses electrons and becomes a blank ion. Losing electrons would create a positive ion. And an example of an oxidation half reaction would be aluminum going to aluminum +3. And where would our electrons be? If it's oxidation, we're losing electrons, so they're going to be on the product or right side of the equation. Now, how many electrons need to be lost to get a +3 charge? 3 electrons. So 3E-. If you look at your half reaction here, this shows on both sides of the reaction the charges are balanced. Equal signs mean that things on both sides need to be equal or balanced. So the charge over here is 0. And the charge over here, if we have +3 and a -3, electrons are negative, that's also 0. That's how you know you're doing your half reactions correctly. Now, where do we see oxidation reactions occur? If you ever notice that an apple will get brown a few minutes after it's cut open, that's because the enzymes are reacting with oxygen and losing electrons, and they're being oxidized. Also, the Statue of Liberty it's not actually that green color. It wasn't always that green color. It's made out of copper, but over time the copper got oxidized by reacting with oxygen and it turned to that green color. Now it's called oxidation because oxygen is the element that is being really reactive and taking electrons from other atoms. Reduction. Reduction is when an atom gains electrons and becomes a negative ion because we're gaining more negative charge. So an example of a reduction reaction can actually be with oxygen. Oxygen can be reduced as well. So we have O -2. Now this is gaining electrons, so where do electrons need to go? They need to go on the left side or the reactant side. And how many electrons do we need to balance this? I see a -2 charge over here and there's 0 charge over here, so that means I must be gaining 2 negative electrons. We can check ourselves. Again, the charge over here is -2 And the charge over here now is -2 because of those two negative electrons. Let's take a look at our little comic down here. The reducing agent, so an element that is responsible for going through reduction, is taking all his electrons and leaving because reduction is gaining electrons. Yeah, that was kind of cheesy. Probably not the best, but what are you going to do? All right, now we're going to practice writing half reactions. So a half reaction is going to show either oxidation or reduction, and you want to look at what is happening from the beginning of the reaction to the end. So we can always split these in half. Here's our beginning or our reactants. Here's the end or the products. Now what's happening here? Copper has a 0 charge and then it turns into a copper with a +2 charge. So it's losing 2 electrons. So if it's losing 2 electrons, what kind of a reaction is this? Oxidation or reduction? It's oxidation. And whenever we have an oxidation reaction, electrons are being lost, so they're written on the right side of the equation. How do we check ourselves to know this is correct? Over here, what's our charge? 0, there's no charge. Over here, what's our charge? A +2 and a -2, also a 0. So we're doing it correctly. Next one is oxygen. You should be trying these in your notes. We split our equation in half. What's happening here? It's going from neutral oxygen to a -2 oxygen. So it's gaining 2 electrons. And what does that mean? That means it is reduction because reduction is gaining. So what does our half reaction look like? Pause the video and try it on your own. The reaction would look like this. Our 2 electrons on the left side because reduction is gaining, so we're gaining more electrons in the beginning, which gives us an overall negative charge. Over here, our charge is -2, and over here, our charge is also -2. Okay, this one I want you guys to try on your own. So pause the video, try this on your own. We have iron with a +2 charge turning into iron with a +3 charge. So the charge is actually increasing, and it's increasing because we're getting rid of electrons. How many? We're losing 1 electron. The charge is increasing. We know that it can't be reduction because reduction means the charge is decreasing. So this is oxidation, and our electrons need to be written on the side that shows they're being lost. So they're being lost, you write them on the right side of the equation. Let's check ourselves. Over here, our charge is +2. Over here, we have a +3 and a -1. We can assume this is a 1 because there's only 1 electron. So that gives us a +2, and I know I'm doing it correctly. Okay, if you need more practice on half reactions, I'm going to link this video in the assignment. This goes through the steps on writing half reactions, and it's super clear. It's a really great video. Other than that, the next thing you're going to do after watching this lesson and finishing your check for understanding questions is you're going to go to our class page and you're going to go to assignment 2. This is what your assignment looks like. Anything that's in a blue box, that's what needs to be filled out, and that's where you need to write your answers. So you're going to get an incomplete half reaction, and then you need to determine, is it oxidation or reduction, how many electrons are being lost or gained, and then complete the half reaction, just like we did in the lesson. And then there are 2 Regents questions for you to answer, and not only answer, but explain how you know that that's the answer. All right, that's it for today. I want to acknowledge you guys for taking on online learning. You guys are doing great so far. So many of you have already reached out, and we're really on top of things on Monday. So, really awesome work. The work for this lesson is going to be due on Thursday, the 26th. My office hours next are going to be on Monday from 2 to 4. But you can always email me and I should get back to you before Monday if you have any questions. And your assignments for this week will also be graded by Monday. So I'll see you guys next week.